Hello, compressed air friends. So we have a Zeks dryer misbehaving today, but that's not really what this video is about. I wanted to show you guys how, with a little bit of resourcefulness, a little bit of working with the OEM, you can get yourself out of a jam here. So if we look right here at this data tag, model and serial number are gone, not even close to being readable. There is literally nothing there. There is no backup data tag on these machines. There is no other means of identification than that right there. So what model of Zeks am I working with here? So I called Zeks tech support, said, hey, I know this is a bit of a Hail Mary, but is there anything we can do? And the guy pretty much said, no, if you don't have model and serial number, you know, one or the other at least, there's not a whole lot we can tell you. And I said, well, this wiring diagram right here, this number is readable. And he says, well, the best that's going to get you is a range. And I said, well, that's fine, that's something. So ran that wiring diagram number, came up with an HSFA 1000 through 1600. Could have been any one of them. I said, okay. So then I downloaded the manual. Hang on here. I downloaded the manual for the HSFA 1000 through 1600 and started to scroll through and look at some specifications, figuring out what's different, because there's a 1000, 1200, and 1600. Just trying to figure out, is there an easy difference we can spot that will tell me what this is? And sure enough, there is. If we come all the way to the end of the parts book here under engineering specifications, we can look at the refrigerant compressor ratings, and the locked rotor amps is different for each model number. So then if we come in here and we look at the data tag on the refrigerant compressor, it's a tight spot, so I'm not going to get a good shot of it, but that data tag is going to tell you that that particular refrigerant compressor has a locked rotor amp rating of 80 amps. So our 80 amp locked rotor amp rating is a 1000 HSFA 400. So still don't have a serial number, but at least I have a model number and I can get parts for this bad boy. So yeah, just wanted to show you guys that. If you ever find yourself in a similar situation, you might be able to use something along those same lines to narrow it down. So that's what I got this morning. See ya. All right, compressed air friends. Back to this dryer that has no name. So the original complaint with this dryer is that we're kicking out on a high pressure cutout alarm. And after running this thing for a little bit, playing with it a little bit, what I have discovered is we have a primary cooling fan kicking on, and when the fan kicks on, it doesn't make much difference in the head pressure. Head pressure just continues to rise like it's not, like that fan's not even there, even though it's running. And when it calls for the secondary cooling fan to come on, the secondary cooling fan's not coming on at all. So at this point, I've done my due diligence. I do know that both of these fan contactors pull in when they are called for. So we're getting power to the fans. It's just that one of them is completely locked up, and that's all well and good, except what was baffling me about this is that it's not that hot of a day out right now, and the side of the dryer over here where the cooling fans are, where the condenser is open to the outside, so there is no restriction coming through there. Obviously I cleaned the condenser. If I look down through there, I can see light through the condenser, so I know it's not completely packed. So I thought, there's no reason why this dryer should be calling for that secondary cooling fan for as nice of a day as it is right now. And so that got me thinking a little bit what might be going on here. And I thought, well, maybe that primary cooling fan is not bad, but just lagging. So once again, I turned to the manual on this thing. And again, this is in the way back of the manual under engineering data. It will actually tell you running loaded amps of that fan should be about 0.95 amps. Locked rotor amps is 2.4, okay? Obviously the fan that's locked up, it's pulling like 2.9 amps when it runs. But watch this. So I'm gonna go ahead and kick this guy on, and that's what my fan that's running is pulling, just below locked rotor amps. So that is what I should be pulling. I'm pulling closer to that. So that stands to reason to me that that main cooling fan is lagging, which is why on a nice day like today, it's even attempting to call for that secondary cooling fan. So basically, at this point, we just need to put 2 new cooling fans in it. We should be good to go. But what I want to stress here, and what I hope you guys get out of this video is a little bit of situational awareness about how this dryer should be running versus how it is running. And you do a little bit more investigation and you find out that, oh, I not only need one cooling fan, I need the other cooling fan. I feel like a lot of technicians out there would have seen the one cooling fan run and said, okay, I know that one's good, I just need this one. I need the one that's not running. In reality, they're both bad. And like I said, it didn't make sense to me that it's a nice cool day out. We're wide open to the outside, like everything. This is an optimal condition for this dryer to be running in. So it didn't make sense to me that it was calling for that secondary cooling fan. And so I pulled amps on that on the main cooling fan and said, oh, we're actually running closer to locked rotor amps than we are actual running amps. So that one's shot too. So, like I said, again, just an interesting one. Starting with the lack of identifying information on it, and then being able to figure that out, and now coming in here to using the engineering data in the back of the book that most of us never scroll to be able to, number one, identify what kind of dryer we're working on here, and then number two, be able to identify that not only has the secondary cooling fan failed because it's locked up and not running, but the primary cooling fan has failed as well because it's pulling amps well above spec, almost into locked rotor amps territory. So I guess the takeaway on this would be always do your due diligence. The problem you can see and the problem you can't see, it's always going to be that one you can't see that gets you. So do your due diligence, think through things a little bit, and just make sure what you're seeing makes sense. And like I said, when I saw this dryer running and I saw it calling for the main fan kicks on, and then it just keeps, the head pressure keeps rising, it calls for the backup fan. It didn't make sense to me that it would be calling for the backup fan on a nice gorgeous day like today. So there you have it, friends. We're going to order up a set of cooling fans for this bad boy and she'll be back in business. I will catch y'all on the next one. See ya.